purpose of today's lesson is to write a function rule when given a particular factual situation. We've done some of this already, but we want to contrast a couple of different types of equations that you can write based upon the situation. Okay, so let's take a look. A kennel charges $15 per day to board dogs. Upon arrival, each dog must receive a flea bath that costs $12, and we want to write a function rule to represent this. Okay, so hopefully that you understand that y is the cost and x is the number of days. And as we've been talking about, x is the input or independent variable, y is the output or dependent variable. Okay, so what is the equation we can write? Y is equal to 15x plus 12. Now, when graphing, especially when graphing a situation that is represented to you as opposed to some just abstract numbers, it probably makes a little bit of sense to make a little bit of a table of values so that you can see what your numbers are, so that you can get an idea of what your axes should be. So I'm just going to fill in over a 5-day period what the cost would be. Now, our x-axis should be days. Our y-axis should be the dollars. I'll skip every other one so we have some spacing. 1, 2, 3, 4, 5. Now, because I know I have to get up to 87, I want to count at intervals that are going to be large enough so that I will get my parameters here. So I'm going to count by tens. Okay, so first thing is you'll notice that if you stay 0 days, it'll cost you $12. Now, I understand from a practical standpoint, you don't stay 7 days and 0 days, pay $12, but theoretically, you could have brought the dog in, gotten the flea bath, and then something could have changed with your plans that you had to leave, so you didn't incur the other $15. So 1 day is $27. 2 days is $42. 3 days is $57. 4 days is $72. And 5 days is $87. Move that off to 1. You should see, because you know this is a linear equation, that your graph should be a line. Now, one of the other things I want to point out, we talked yesterday about discrete and continuous functions. Technically, this is a discrete function because you would be charged per day, not partial days. The other thing that I would point out is that your domain, which is the number of days, is restricted because you're not going to have negative days, obviously. You're not going to have partial days. Okay? So that's the graph of this particular relationship. Okay? And you'll see that when we put the equation together, it was in y equals 4. All right? We clearly had an independent days and dependent variable. Now let's go to the next section. Example. I'm sorry. A media download store sells songs for $1 each and movies for $12 each. You have $60 to spend. Write an equation for the number of items you can buy and graph it below. Now, again, let's start by identifying what our variables are, because that is always helpful in these types of situations. So, my two unknowns in this situation is that X, I'm going to say, are songs, and Y is the movies. Now, if you think about it, you could have switched those around, because technically one is not independent and the other dependent. One does not create the other. You don't have to buy the movies and restrict the number of songs. You have a choice of what to do. Now, what's the equation to represent this? X plus 12y equals 60. Now, you could convert this into y equals form and set up a table of values and graph it. But if you might remember, we did another graphing technique a little bit a while ago that would serve this. But let's do the following first. Let's put songs here, and let's put movies here. Since we identified songs as the x, it has to be our x-axis. Okay? Now, what might be a good technique is to find my x and y intercept. Well, what's my x-intercept? Well, that's when y is 0. So my x-intercept is 60. My y-intercept is when x is 0, and that's 5. What you've just figured out is if I buy no movies, I can buy 60 songs. And if I buy no songs, I can buy 5 movies. So what I'm going to do is the maximum number of movies I can buy is 5. So that's why I'm counting by the ones there. And the maximum number of songs I can buy is 60. So I'm going to count by 10s here. Now, the simplest thing to do is to graph my y-intercept, my x-intercept, and connect the two. Okay? And you could figure out, if you want to, any other potential points in between or combinations that will work. Now, if you also might remember, when we did graphing inequalities, if this was an inequality, then anything below the red line, including the red line, would satisfy the condition, okay? Meaning if I had $60 or less to spend, right? So that's how that all ties in. Now, how do the equations in the two pub examples differ? And how does the approach to graphing them differ? Okay? Well, the first one was written in y equals form, or what's called slope-intercept form. While the other was not. Okay? Also, the number of days clearly causes or results in the cost of boarding. That is not true in the second example. Okay? So, in the first one, we graphed by making a table of values or using the slope and the y-intercept, while in the second one, we used the x and the y-intercepts. Well, that second equation is what's called the standard form of a linear equation. And the standard form is ax plus by equals c, where a, b, and c are constants, are real numbers, really, and a and b are not 0. If a and b are 0, then all we have left is the constant c. Okay? Okay, so let's take a look at the next one. Write a function rule for the area A of a rectangle whose length is 5 inches more than its width. Find the length and width if the area measures 126 inches square. Well, let's set up the width we're going to call x. I mean, you could call it w, but that's fine. And L is going to be x plus 5. What's my function rule? The area equals x times x plus 5. Well, now, how do I find? Now, let's just do one thing here. Is this a linear function? Right? And how would I answer that? Well, take a look at what the equation would look like when I extended it out. A equals x squared plus 5x. This is not a linear function because, as we talked about yesterday, the x is squared, okay? And I'm putting a there for area. You could put y there if you wanted to, if this was something that's going to be graphed. Now, I want to figure out what it is when it's 126. What kind of equation do I have? I have a quadratic equation. Now, everybody's sitting there saying, how the heck do I figure out what multiplies, because I need to know what multiplies to negative 126 and adds to a positive 5. And since it multiplies to a negative, I know one of them has to be a negative. Well, there's a very simple way to do this. I'm going to take the number 126 and I'm going to do a prime factorization, meaning I'm going to break it down until all I have are prime numbers. And the circled numbers are the primes, 2, 3, 7, 3. So 2 times 3 times 3 times 7 is equal to 126. Now, how does that help you here? Well, what you're going to do is some combination of these numbers multiply to 126. In other words, 2 times 3 and 3 times 7, so 6 times 21 is 126. Well, what you can now do is play around with these numbers to figure out how can I pair them up or partner them up so that I get some combination that works here. And when you do that, and this at least limits the number of pairings you're going to have, what you'll see is that your numbers are going to be a positive 9, a negative 9, and a positive 14. Because if I take 3 times 3, that's 9, and 7 times 2, that's 14, that gives me my result. Okay? So now I factor this as x minus 9, x plus 14. Remember to set these equal to 0. Many of you are stopping at this step. So that x is 9, x is negative 14. We disregard negative 14 because I cannot have a negative length of a rectangle. So my width is 9 and my length is 14. Okay. Last example. A store sells gift cards for either $10 or $25. You have $250 to spend. Write a function rule. So X is the $10 card. Y is the $25 card. 10X plus 25Y equals 250. Okay? So, what's the easiest way to graph this? Well, you'll see that this is set up in standard form. So my recommendation, I have the $10 card here. And, sorry, I need to put the $10 there. $10 card, $25 card. Okay, I'm going to find the intercepts. So I can buy, so my x-intercept is I can buy 25 $10 cards, and my y-intercept is I can buy 10 $25 cards. So that gives me my parameters. Count by fives. So my x-intercept is 25. I'll count by fives here. My y-intercept is 10, and I could just simply graph as such. Okay? So, the point today was to show you how you write a function rule and how your function rule may be different depending upon the facts that you were given. It can be written in the slope-intercept form, which is the y equals form, if you have a clear independent variable, or it can be written in standard form when there's clearly no one variable that generates the other.